Hi, I'm Arthur Padgett, and I'm here to do a quick little intro on analog to digital conversion. Alright, there's three main points when you're doing analog to digital conversion. There's the range, and that's something I'll talk about, resolution, and sample rate. Alright, range. Range is the voltage of the voltage range that you can actually measure with your analog to digital device. So when you're looking for a analog to digital device, you want to make sure the range fits your needs, or that you can change the range with physical components to meet your demand. For most chips, the analog to digital conversion chip is powered off the VCC. So if you have a 5-volt logic chip, you're going to be able to measure between 0 and 5 volts. If you're using 3.3, you'll probably be able to measure between 0 and 3.3. What that means for measurements is, if you're measuring a 10-volt source and you have a 0 to 5 volt converter, anything above 5 volts you're not going to be able to measure. So what you can do is use a voltage divider, which is a network of resistors used to step the voltage down by a ratio. This is an example of a voltage divider. As you can see, you have two resistors that would be in series with each other. Here would be the voltage that you want to measure eventually. You have your network, and then this would be your measurement pin on your chip. And here's the equation you use. And so I use a voltage divider. Resolution. Resolution is something that's defined by your particular conversion chip. You'll hear when you're looking for a chip, 8 bits, 10 bits, 12 bits. That's describing the resolution. And the more bits of resolution you have, the better your measurement's going to be. And you can think of that kind of like pie. If you want a particular slice of pie, the more cuts you can make, the closer you're going to get to that particular slice. So here you only have, looks like, 1, 2, 3, 4, 5, 6, 7, 8 choices. But if you double the cuts, you'd have 16 choices, and every time you double that, aka adding a bit, you're getting closer to the sample rate. Sample rate means if you're measuring something, let's say the frequency of a wall outlet, that's 60 hertz. Most microcontrollers can handle that. But more high-speed applications are going to need something a little faster. So when looking for an analog to digital conversion chip, you're going to want to look for your range, you're going to want to look for your resolution, and you want to look for your sample rate. Here I'll turn this here. You can get it close up. This is a little bit what the sample rate can do for you. You see this bar graph here. If you only take samples at the particular lines, your end result's going to look like a square wave from this line down to here. And obviously that's not what this particular wave looks like. So if you sampled halfway in between, you'd get there, and it would look more like a diagonal line rather than, and every time you get closer, you make more samples, just like the pie, you get closer to the actual signal. And another thing, the higher the sampling rate, the more expensive your chip's going to be. So if you're going to measure something slow, like for instance, for a microcontroller, most music is considered slow. So you could use a normal microcontroller analog to digital converter for that. If you're measuring something in the high kilohertz to low megahertz range, you're going to want something a little better.